Good morning, dear students. Today we are going to discuss NTA mock test number 13. So we will be discussing mostly all the questions here. Look here. We have 3 beakers ABC containing glycerin, water and kerosene. Okay, so they are stirred vigorously and placed on a table. The liquid which comes to rest at the earliest is, we can see here which will come to rest at the earliest. See, when you stir them, right, which will settle down first? The one which has more viscosity, that will settle down first because it has more intermolecular forces, so it will try to settle down faster because it resists its motion. Okay, so that's what viscosity means, right? The layers will be resisting each other from the motion. So that's the reason here. We can see among these glycerin, water and kerosene, you can just put a common sense also. You can understand glycerin will be having little more viscous nature compared to water and kerosene. So glycerin going to settle down first. Glycerin gets settled down first. Understand? So this will come to rest at the earliest. That's it. Next, a block rests on a fixed rough inclined plane and a horizontal force F is applied to it. So as shown in the figure. Then which of the following statements are correct? You are applying a horizontal force, so you need to understand. So you have kept a block here. You are applying a force in this direction, F. As you can see, there is a normal reaction here, N, right? You can see this F which you are applying here. This F you can resolve into components. F component in this direction is F cos theta, and F component in this direction is F sin theta, and also mg is there for you, right? This mg is also having components here, so this will make an angle theta here. So this side the component is mg cos theta, and this side the component is mg sin theta. First, immediately resolve the forces into components. So the overall force in this direction is F sin theta plus mg cos theta, and in this direction is N. So for the balancing of this particular block, the block is at rest, you can see that this N must be equals to this. It means the normal reaction is F sin theta plus mg cos theta. At the same time, what you can write about frictional force is 0 when F cos theta equals mg sin theta. Yes, when already these two forces are balanced, so there is no point of friction here. So that's why you can say the frictional force is 0 when F cos theta equals to mg sin theta. So these are the 1 and 2 options here which are correct here. Understand, right? So limiting friction is nu into n, which is nu into n. N is this. So it should be nu into this thing. So that is not there here. So that's why only option 1 and 2. Right? Now, the coordinates of the center of mass of the following circular arc are. So for this quarter circular arc, what is the coordinates of center of mass? Generally, you know, for a semicircular arc, what are the coordinates here? Semicircular arc, you know, here will be the center of mass. That will be at a distance of 2r by pi. So it is 0, 2r by pi, right? Everybody knows that, right? Semicircular arc, semicircular wire, only semicircle, only this much. For that semicircular wire, the center of mass will be at a distance of 2r by pi. Now, quarter circular wire is given for us. If you look here, only this portion is given for us, okay? So if you observe here, if you take this portion center of mass to be here, then this portion center of mass to be here, then the resultant of these two will be where? The center of mass of the system should be here. It means the center of mass of this portion should be here and here, right? Then only the center of mass of the system will be here. Yes or no? Understand? So that's the reason you can say that. And this is symmetric along x and y axis. You can symmetrically divide this. So the center of mass of this particular thing should be at 2r by pi, comma 2r by pi. And similarly, this center of mass should be this side, minus 2r by pi, comma 2r by pi. So that the center of mass of the system will be here, on this line, right? In this line, if you observe, center of mass of the system will be here. So that's how I can say. Just you have to see the symmetry and think about that, then you can answer it directly. No need to solve it and start solving here. Just see if you assume one more portion here, what you could say? The center of mass of system should be here. It means center of mass of this should be here, this should be here. It means the center of mass of this is at 2r by pi, comma 2r by pi. Clear, everybody? Understand? 4r by pi is not possible. If center of mass of this portion is 4r by pi, 4r by pi is somewhere here. Okay, then center of mass of this portion is also somewhere here. Then these two resultant won't be here. Right? Okay. So that's what we can say here. 2r by pi, comma 2r by pi. Okay. So that's what we can say. So that is option C here, 2r by pi, comma 2r by pi. Now let's look into the next question. A radioactive material has mean lives of 1620 and 660 for alpha and beta emissions respectively. Then the material decays by simultaneous alpha and beta emissions. So the time in which the 1/4 of the material remains intact is. Mean lives are given 1620 and 660, right? So what do you say? Lambda for simultaneous reaction when alpha and beta are happening here. So lambda for the resultant reaction is lambda alpha plus lambda beta. This is what we can say. So lambda alpha is 1 by mean life 1620 and lambda beta is 1 by mean life, that is 660. We have already solved this type of question previously in the mock test. I think you know the thing here. So this is a lambda for this particular thing here. Then similarly we know that 1/4 of the material intact means 1/4 remains, 3/4 is decayed. When 1/4 is remaining, n by n naught equals to 1/2 into t by t half. So how much is remain here? N is the number of nucleons at the particular instant, that is n naught by 4. So 1/4 equals to 1/2 whole power t by t half. It means t by t half is equals to 2 because this is 1/2 whole square, right? So time is how much here? 2 times t half. And what is your t half? T half is ln 2 by lambda. Is that okay, everybody? So substitute the value of lambda here, means 1, okay, right? And you can get the result here. So that's going to be, I think, 650 years you will be getting here. 650 years. You will be getting 650 years. Understand? So substitute the value of lambda here. You need to solve little bit of calculation is there. Actually the value should be little more good values should be given here. But unfortunately we have these things. So we can't do anything here. We just need to solve it here. You can make some approximations if you need and you can get it done. Understand? Right. So values are also little close. 650 and 720 is there. So you need to solve it here. No other way. Understand? So that's the thing here. Two wires A and B of the same material have radii 1:2 and carry currents in the ratio of 4:1. Then the ratio of drift speed of electrons in A and B. So drift speed of electrons you can solve it by using the formula current I equals to NEA VD. So just compare the currents and radius. They are same materials, so N will be same. So we have to understand only the differences coming in current and area here. So this is I by A. So your drift speed, it's proportional to I by A. Remaining things are same. So ratio of currents are what? Radii ratio is 1:2. Current ratio 4:1. So current ratio is 4/1. And this is I by A. So inverse ratio, that is again 4/1 because the area R square, right? So R1 by R2 is 1/2. So R2 square by R1 square we need to substitute here. So that will be your 16:1. Make it fast. Understand? So that's how you can solve it here. Clear, everyone? Right. Now look into the next question. K1, K2 are the maximum kinetic energies of photoelectrons emitted when light of wavelengths lambda 1, lambda 2. Similar question we already discussed in the previous mock test also. Again, the same thing they are asking here. Now look here, maximum kinetic energy formula is what? This is energy which is incident minus phi, right? Work function. So K1 is the initial thing here. So that is K1 equals to energy is hc by lambda 1 minus phi. Then K2 is hc by lambda 2 minus phi. What is lambda 2? Lambda 2 can be written as lambda 1 and 3 here, right? Yes or no? Lambda 1 by 3. So it's like this, K2. And if you multiply K1 with 3, you will get 3K1 equals to 3 hc by lambda 1 minus 3 phi, right? And this is K2. So this is 1, this is 2. Again 1 minus 2. What do you get? 3K1 minus K2, which is equals to, right, minus 2 phi you will get. Yes or no? This minus this, minus 2 phi. So that's nothing but less than 0. Phi will be always positive, work function, right? So it means your 3K1 minus K2 is less than 0. It means what do you say? K1 is less than K2 by 3. K1 is less than K2 by 3. If you do like this, you will easily get the answer. So this is how you need to simplify. We already solved this type of question. Again it's coming. There it's given lambda 1 equals to 2 lambda 2. It's given lambda 1 equals 3 lambda 2. Nothing much difference. You need to eliminate this hc by lambda 1 thing here. I need to compare between K1 and K2. That's how you can do it. Clear everybody, right? Next question. If you don't understand, you can go back and you can look into this, but I need to move forward. So that's why here. In uranium 92, K absorption edge is 0.107 angstrom and K alpha line is 0.126. Then the wavelength of the L absorption edge. See, you can see the energy related to K absorption edge, right? K absorption edge. What you can write is these things here. This is actually K, L, M, N, and so on. So here somewhere, let's say there is infinity here. K absorption edge is the energy related to K equals to or N equals to 1 to here, till here, infinity. This is the energy related to K absorption edge. Similarly, energy related to L absorption edge is from here to here. Then what is K alpha? K alpha related to here to here, right? When an electron is removed from the K shell, and if due to X-rays, right? When electron is get vacant over here, when one electron comes and hits over here, if electron is removed from K equals to N equals to 1 shell, and if the electron is in the higher energy levels or higher these things, L, M, N, higher levels, if it is coming back to K shell, then it's a K alpha you are going to get, right? So if something is coming from M shell, then you will get K beta. Like that you are going to get here. So K alpha is related to N equals to 1 to N equals to 2. So this is the energy related to K alpha. From this diagram you can easily understand EK equals to EL plus EK alpha, right? Simple way of solving this. EK equals to EL plus EK alpha. Yes or no? Right? So that's the thing. Now EK is what you can write here, hc by lambda, K absorption edge 0.107. EL is what? We don't know. L. Then K alpha is what? This thing, hc by 0.126. No need to substitute hc values and all, because many people will be keep on solving, but not required to substitute hc values and all, because hc gets cancelled here simply. So directly you can get the value of L lambda L. That lambda L you are going to get approximately 0.7 angstrom from this. Understand? Next, that's the thing here. Easy way of solving. A camera objective has an aperture diameter d. If the aperture is reduced to diameter d by 2, then the exposure time under identical conditions of light should be. Exposure time. The exposure time is going to increase because you are decreasing the diameter of the camera. So you are decreasing the aperture. So the less light is going to enter. So it takes more time to capture. Understand? Means when you open the cameras, okay, that blocking thing, when you open it, it takes more time for the exposure, means to get the clear picture, because you are decreasing the diameter, you are decreasing the lens aperture. Lens aperture means that front part, how much area is there. So that is the thing here. So that's why when you decrease the diameter, it means you are decreasing the area. So the exposure time will increase. How much time it will increase? The exposure time is proportional to 1 by area. 1 by area square. 1 by area, that's it, not area square. It's inversely proportional to area. Or it's inversely proportional to 1 by diameter square. So here diameter is decreased by 2 times. So your exposure time will increase by 4 times. It's increased by 4 times. That's it. Understand? Aperture diameter they mention. If they simply mention aperture is decreased by 2 times, then the exposure time will increase by 2 times. Aperture diameter is decreased by 2 times, so exposure time will increase by 4 times. Okay, sometimes they will write the time will be proportional to 1 by aperture, inversely proportional. Aperture means what? It's an area we need to consider. But here they mention aperture diameter is decreased by 2 times. So exposure time will increase by 4 times because area is diameter square, you are going to get pi d square by 4. When an object is at a distance x and y from a lens, a real image and virtual image are formed respectively, having the same magnification. So focal length of the lens is, you can take any lens for understanding. Generally what do you write lens formula here? 1 by v minus 1 by u equals to 1 by f. So 1 by v equals to 1 by f plus 1 by u. So v equals to uf by u plus f. Our magnification you can also write, that is f by u plus f. What is magnification? V by u. So this is the general formula for magnification for any lens, right? F by u plus f. Keep it like this. They mentioned when object distance is initially at x. So what is the magnification that time? F by x plus f. Yes or no? So magnification is f by x plus f. So you are keeping the object, right? Real object you are keeping. So definitely the object distance will be negative, right? If you put the sign convention. Let's say you are looking for convex lens. You can do it for any lens. In general you can take some lens and you can find it also, right? So that's why. So this thing. Then another case, you are keeping the object distance at y. See, the thing is, you are getting a real and virtual images. So real and virtual images should be inverted. Means both are like opposite. I mean, one is erect and other should be inverted, something like that, right? They can't be on the same side, or erect and that they can't be inverted both. So for one lens, for one particular lens, if you take a convex lens generally, right, real image means it will be inverted, right? Virtual image will be somewhere, it will be formed here. This is a virtual image, real image. So by changing the object distance, right? So virtual and real, you can see the magnification will be, okay, inverted things. But the magnitude is same. They are saying the same magnification. Same magnification. So based on that, what I can say is, your m1 equals to minus m2. So f by minus x plus f equals to minus f by minus y plus f. Then you can write minus y plus f equals to x minus f. So 2f equals to x plus y. Then f equals to x plus y by 2. Understand everybody? Right? So that's how you can make it. Understand? So that's the thing here. Right. Next, let's look into next question. We need to solve all the questions, mostly all. So we need to go for faster little here. Then if you don't understand, just go back again and watch it. You will understand. If you feel like it's moving fast, then you can go back and watch it, no problem. In the given circuit, the average power developed is average power formula based question. What is the average power? Vrms into IRMS into cos theta, right? That's the average power. Vrms into IRMS into cos theta. In terms of V0, I0 also you can write. This is also you can write. You can see L is this. So what is your XL? XL equals to omega L. Omega is 250 and 0.2. So that will be 50. Then R is also 50. If you make a small this thing here, this is the direction of R, this is the direction of XL. And what do you say about your theta? Theta will be 45. Yes or no? This is 50, this is 50. So this will be 45. I mean 45 degrees. It goes exactly like this because these two are equal. Yes or no? Right. Then cos theta is how much? Cos theta is 1 by root 2. Okay, keep it like this. And what is Z? Z is root of XL square plus R square. That will be 50 root 2. 50 root 2. Chala. Clear? Let's find out now. Vrms. Vrms is what? V0 by root 2. Right? So 200 by root 2. IRMS. IRMS is what? Vrms by V equals to IR. I equals to V by R. So Vrms by Z. Getting or not? IRMS equals to Vrms by Z. Vrms is 200 root 2. Z is 50 root 2. Then what is cos theta? Cos theta is what? 1 by root 2. Okay, so how much you are going to get? 200 into 200 divided by 50 into 4 2s. So 2 into 2. Root 2 into root 2, 2. Root 2 into root 2, 2. 50 into 4. How much? 200. Gone. So 200. Your power. Sir, power is 200 watt. Answer is 200 watt. Any formula. Either you can write V0 in terms of V0 also there is a formula. You can remember like that. R Vrms into IRMS into cos theta. Vrms is what? This is V0. This is V0. V0 by root 2. 200 by root 2. IRMS is what? Vrms by Z. Vrms by Z. Cos theta is what? 1 by root 2. R by Z also you can write in that way. R by Z. That's the average power formula. So current of 10 is passed through in the first coil, which induces a maximum EMF of 5 pi in the second coil. Mutual reluctance between the coil size. Mutual reluctance, what you can write here? EMF induced equals to minus of M into di by dt. When you are changing current in one coil, EMF induced in the other coil. Yes or no? Right? When you are changing current in one coil, EMF will be induced in the other coil. So that's what we can write here. So what is the EMF you are in developed? M into di by dt. What is di by dt? 10 sin theta is what? Cos theta. Sin theta is cos theta. And inner function also? Yes. What is the what is the maximum value of this function here? Maximum value of this function is this much. That's 1000 pi m, which is equals to what? 5 pi. It's given. Then what is m? M is 5 millihenry. Simple. Understand? Clear, everybody? That's how you can solve it. I'm telling you, if you don't understand, look back. Now let me go for the next question. What will be the magnetic field at point P in the figure below? Magnetic field at point P here. Very simple question. It's a semicircular wire. So what is the magnetic field? Nu naught I by 4R. And there is a magnetic field at this point due to semi-infinite wire. It's going like this. What is the magnetic field at this point? That will be nu naught I by 4 pi R. Right? Semi-infinite wire. So, whatever, direction is something like this. We can see due to this outward, due to this outward, due to this also outward. So all will be added up. So due to this wire, this thing. Due to this wire also same thing. So 2 times of it. So this is the net magnetic field. So bring the nu naught I by 4R outside, you will get this. Understand? Right? Time period of vibrations. So answer is nu naught I by 4R, 2 by pi plus 1. Option B. Now, the time period of vibrations of a dip needle in the vertical plane in the magnetic meridian is 3 seconds. What is the when the same magnetic needle is made to vibrate in the horizontal plane, the time period is 3√2. Then the angle of dip will be angle of dip. Time period of vibration, you can write what? Time period is 2I by mb. So in the vertical plane it is 3. In the horizontal plane 3√2. So it is 3 here. In the magnetic meridian, okay, vertical plane in the magnetic meridian. So that is 3, which is I by mb. In the vertical plane in the magnetic meridian, we need to consider the B effective here. B effective. The B effective you need to consider in this particular case. Then when the same magnetic needle is made to vibrate in the horizontal plane, so that's giving you 3√2, right? I will be same, M will be same, but B will be B horizontal in this particular case. So that's a effective magnetic field you need to consider when it's vertical plane in the magnetic meridian. In the magnetic meridian, so that will be effective magnetic field you need to consider. But here it's a horizontal plane, so BH you need to consider. You know that B will be like this. B. This is B effective. This is the horizontal one. This is the vertical one. This is theta. So if you take the ratio of these two, what do you get? 1 by √2, let's say. This by this. This is 1. Let's say this is 2. So if you do 1 by 2, what are you going to get? So that gives you root of B horizontal by B effective, right? B effective. So we also know that B horizontal is what here? BE cos theta effective. Then 1 by 2 equals to cos theta. It means theta equals to 60 degrees. That's how you can solve it, right? Now let's look into the next question. If only 1/100th of a total current flowing in the circuit is to be passed through a galvanometer of resistance G, then the value of shunt resistance required will be. This is a galvanometer, shunt resistance is yes. So the total current is I through galvanometer, only Ig is flowing here, right? So what do you write about Ig here? Ig is I into S by G plus S, where G is the galvanometer resistance, S is the shunt resistance. It's given that 1/100th of a total current is flowing in the circuit. So Ig is how much? Ig is I by 100, right? So what do you say? 100S equals to G plus S. So what is your shunt resistance? This will be G by 99. Okay, that's it. Now, so separation between the plates of parallel plate capacitor is given 5 mm. Then the capacitor is having some air inside, dielectric medium as the dielectric medium. Initially air is there, then later the potential difference is 25. Now the battery is disconnected and you have kept a slab. So battery you have removed. Whenever you remove a battery, keep one point in mind, the potential won't be same. Battery is removed. When battery is connected, then the potential difference is same. When battery is removed, charge will be same. So your charge will be constant when battery is removed. So keep that point in mind. Charge is constant. Initially charge atra Q equals to CV, right? And what is C? C equals to A epsilon naught by D. Okay, D into V. V is 25. Initially, this is the charge. Finally, what is the charge? You have kept a dielectric constant of 10. Then what will be the equivalent capacitance here? 1 by C equivalent equals to 1 by C1 plus 1 by C2. Everybody know it? C1 is what? A epsilon naught by D minus T if you kept a slab of thickness T. Then what is C2? A K epsilon naught by T. If you have a slab of thickness T and this is D and this is K, this is A, this is the situation, yes or no? Hey, everybody, yes or no? So this is the thing, right? 1 by C equivalent. Then what is the charge? Q equals to CV, right? So if you simplify this, 1 by A epsilon you can take outside, D minus T plus T by K. Chalo, what is the charge final? CV. What is C? A epsilon naught by D atra 5, T 3. So let me substitute that things. CV, right? Final voltage is VF. But charge initial equals to charge final, right? So when you equate these two, A epsilon naught gets cancelled. Then what you left here? 2.3. Chalo, equate these two. What do you get? VF by 2.3 is equals to 25 by, what is D here? D is 5. So your VF equals to 11.5. That's how you can solve it. Understand, everybody? Keep one point in mind. When battery is connected, potential is constant. When battery is removed, charge is constant. Okay, so accordingly you need to write it. Initial charge, final charge. It will not go anywhere because battery is removed. So those two you need to equate. Right. Next. Capacitor of capacitance 100 is charged by connecting a battery of EMF 12 volt and internal resistance this. Then time taken before 99% of the maximum charge is stored on the capacitor. Yeah, you know this thing, right? What is the charge on a capacitor? Q equals to Q naught into 1 minus e power minus t by RC. So 99% of charge is stored. It means 0.99 here, right? That's 1 minus e power minus t by RC. R is 2. Capacitance is 100 into 10 power minus 6. That's it. This is 0.01 equals to e power minus t by 2 into 10 power minus 4. This is 10 power minus 2. e power minus t by 2 into 10 power minus 4. So 2 ln 10 equals to t by 2 into 10 power minus 4. So t will be, you will be getting it as, what is it, 0.92 milliseconds. You can get it. Next, the EMF is given, that's not required for us. Directly charge q equals to q naught into 1 minus e power minus e by r. That's it. Which of the following statements is correct? Lens is dipped in water, magnitude of focal length increases. Lens is dipped in water, magnitude of focal length decreases. Spherical mirror is dipped in water. Spherical mirror, nothing is going to happen, right? Mirror is kept inside water. There is no difference because radius of curvature is same, focal length will be same. Listen to my words carefully. If you don't understand, listen back. Go back and listen. Now, lens is dipped in water. Then what will happen to focal length? Yeah. What is the focal length here? Nu2 by nu1 minus 1 into 1 by r1 minus 1 by r2. So let's write 2 by r here. It may be concave or convex later. You can write. Magnitude only they are asking here, not the sign. Nu2 by nu1. If you kept in water, what will happen to this value? Initially is what? Initially, this is nu2, this is nu1. See, this is nu2 and nu1, right? Generally, in case of lens. Now you see here, when you kept in water, nu1 increases. When you kept in water, nu1 increases. Nu1 increases means this value decreases. So this whole value decreases. This whole value decreases. It means 1 by f decreases. It means f increases. That's it. That's the thing. Understand? So focal length is going to increase. The magnitude of focal length increases. Simple logic. Nu1 increases. This will decrease. So 1 by f decrease, f increase. Why nu1 increases? Because you have kept in water. When you kept in water, initially and it is in air, nu1 is 1. When you kept in water, it will be more than 1. So when nu1 is more, nu2 by nu1 will be less. So this overall value is less. 1 by f is decreasing. It means f is increasing. That's it. 18th one is repeated again. Fine. 25 watt 220 volt, 100 watt 220 volt are joined in series. Then which bulb will glow brighter? Which glows brighter? Simple logic. By sub, two bulbs are there. See, the current is same, right? First of all, look at the resistance. What is the resistance here? Resistance is what? V square by P. Right? For 25, P1. This is 1. This is bulb 2. Then R2 is V square by P2. Which one is more here? Here this P1 is less. So R1 will be more. R1 is greater than R2. Yes or no? P1 is less. So R1 is more. R1 greater than R2. When R1 is greater than R2, what do you write about the power of this bulb? Power of this bulb, can I write I square into R? I can compare because I is same, right? See, power formula you have to write as per your wish. As per your wish means according to the situation. In this situation, if I write power formula I square R, then it's good for me because I can compare easily. Because I is same. So which one will grow? Which one will have more power? The one which is having more resistance. Which one is having more resistance? R1 is greater. It means 25 watt bulb is going to give more power. That's it. Can't believe. Understand? So there is a sphere of radius 3a, concentric spherical cavity of radius a. A point charge q is there at the center. This radius a. Okay. Something like this, you would have plus q, a, 3a. I need to know the potential at a position of 2a. 2a means somewhere here. See, this is a conducting shell. Conducting means potential from here to here it is same. If I know the potential on the surface, that is same as potential here, anywhere inside, because it's a conducting shell. When there is a plus q here, here minus q will come obviously, and here plus q will come here. Gauss law. I'm not going to explain that. Then what is the potential on the surface? Potential on the surface will be kq by 3a, obviously. kq by 3a minus 3a will cancel. You will be left with kq by 3a. Yes or no? So that's the potential on the surface, which is same as potential inside, resistance of 2a. Understand? kq by 3a is the potential. That's it. 2 point charges placed at a distance r in air exert a force F. Then the distance at which they experience force. Force formula here, kq1 q2 by r square. K means 1 by 4 pi epsilon naught. Then the force is become 4F when 1 by 4 pi some dielectric constant 16 epsilon naught, k epsilon naught. The distance is r1 square, let's say. Finally the distance is r1 square. Then just take the ratios, this by this or that by this, whatever. Then you will get the r1 value. R1 value which you are going to get is r by 8. Take the ratios, you will get the value of r. That's it. Simple questions. I am moving fast. Root mean square speed of oxygen molecules are given. Then the temperature is doubled, but oxygen molecule gets dissociated into atomic oxygen. Then the root mean square would be, initially root mean square is v, which is root of 3 RT by m. Finally root mean square is v, temperature is doubled to 2T and molecule gets dissociated, so m becomes m by 2. So overall you will get it as 2v. Yes or no? 2 to 1 2 will come out. That's it. The root mean square speed would be increased by 2v. First you solve the question. If you don't understand, then you look at the solution. Understand? Right. Pressure and volume of a given mass of a gas are P and V respectively, keeping the temperature constant. The pressure is increased by 10%. Then the system is allowed to achieve the steady state. Then the pressure is decreased again 10%. Then what do you say about the final volume? Initially the pressure is increased by 10% here. It means pressure becomes 1.1 P. Is that clear for anybody? Pressure increased by 10% means it will become 1.1 P. Then the volume should become what here? V become 1.1. Then only the PV should be constant, right? Because the temperature is constant. P is inversely proportional to V. PV should be constant. Pressure increased by 10% means P becomes 1.1 P. Then what should be V? V should become V by 1.1. Yes or no? And that is the thing here. Then pressure is decreased by 10%. What do you say about final volume? They are saying pressure is decreased by 10%. Initially, okay, at this point the pressure is 1.1 P, which is decreased by 10%. 10% means what here? 0.11 P. Yes or no? Here decreased by 10%. See, clear, make it clear, please. Okay, 1.1 la 10% etra. Okay, 0.11. Okay, so this will give you 0.99 P. So the pressure you decreased by 10% now. That is 0.99 P. Then what should be your final volume? Your volume should be V by 0.99, because again when you multiply this into this you have to get PV, because you are keeping the temperature as constant by sub. Yes or no? So your volume should become V by 0.99. When the volume becomes V by 0.99, the meaning is what? V becomes 100 V by 99. 100 V by 99 is more than V or not? It means your volume has finally more than V. Finally the volume is more than V. It's little bit of simple mathematics here. Percentages you should know. 10% of P. P is there. In this 10% means 0.1 P. Understand? When there is 1.1 P, in this 10% means 0.11 P. When you increase means 1.1, decrease. Understand? Okay. Okay. Clear? Okay, the volume becomes more than V. That's the thing. Initially you have temperature kept constant, pressure is increased. Pressure increased, volume has to decrease. Later also pressure you have decreased by something, but finally pressure into volume should become P into V, PV. Pressure is finally 0.99 P. It means volume should be what? V by 0.99. Then only 0.99 gets cancelled and PV you will get. Okay, so that's why final volume is V by 0.99. If final volume is V by 0.99, then it is 100 V by 99, which is more than V. More than V. ABCD of different metals, same radius, are kept with the same temperature, then the ratio of density, specific heats, which sphere will initially show the faster rate of cooling. MS some d theta by dt EA sigma T power 4. This is what, right? Newton's law of cooling. Yes or no? This is the thing, basic thing. I'm not giving the complete expression also. T power 4 minus some TS power 4 is also there. I'm not writing all those things. If you want to, you can write whatever it is. We need to compare what? This d theta by dt, rate of cooling I need here. Everything is same except A, same radius. So A also not needed, E also not needed. We need the density, we need the mass. So your d theta by dt, density by mass and specific heat. That's what only we need to compare, only this thing. Remaining things are same for everything. Only this we need to compare. It means your sigma by ms. But again, what is ms here? Mass is density into, sigma is the Stephens-Boltzmann constant, right? So that is also same. Is a Boltzmann constant. That's not required for us. Boltzmann constant is not required because it's same. So only we need to compare is what? Mass is density into volume. Volume is same because radius is same. Density into volume. So density into S. Specific heat capacity we need to compare. 1 by rho S. First of all, rho into S is what? Rho into S. When you multiply, what you are going to get? 6 is to 18 is to 10 is to 4. That's nothing but 3 is to 9 is to 5 is to 2. So this is a rho into S ratios. So in this rho S, which is more here? They are saying faster rate of cooling means d theta by dt should be more. It means rho S should be less. Rho S is less where? Here. Yes or no? Right? Yes or no? Rho S is less. It means your D should show faster rate of cooling. That's why. Basic. D theta by dt should be more. It means rho S should be less. Where is the rho S less? Rho into S. This is less. Next. Man is standing between a stationary source and cliff. When it starts moving along the line, joining him and source, he hears 10 beats per second. The velocity of the man is okay. The concept is there is a cliff, there is a man, and there is a source. Object. The speed of sound wave is Vs. V. Sound waves. These sound waves are going here. I mean, from the source it's coming here. And this, from the source also, it comes to this cliff also. From the source, the sound waves come to cliff. After reaching the cliff, again the cliff will behave as a source of sound. So for this man, the man is moving towards the source. At the same time, the man is moving away from source. One slide. That's the concept here. Man is moving towards the source, and also the man is moving away from source. Understand? So that's why when man is moving towards the source, what is the frequency? V plus V naught by V into F. When man is moving away from source, what is the frequency? V minus V naught by V into F. Difference is what? That's a beat frequency, 10 beats. So your 10 equals to 2 V naught F by V. Substitute the values. The frequency value is given 600 and speed of sound is 330. Then you will get your V naught, and V naught will be, I think, 11. You will be getting it as 2.75. Understand? That's what you can solve it here. The transverse waves and another wave is also generated. So the P wave arrives 5 minutes before first S wave. So P wave is traveling faster, right? So P wave is traveling faster. It takes less time. S wave takes more time. When S wave is taking more time, what is the time taken by S wave? Let's say that epicenter is located at a distance d. So d by this is 6 minus d by 9. This is the time difference, which is 5 minutes. Yes or no? Distance by speed is time taken, right? So time taken by this wave minus time taken by this wave is the 5 minutes difference between the both waves. Then what is the value of d? So the d value you are going to get 5400 kilometers. Solve it properly, you will be getting it. Time period initially, okay, it's having a length L. Initially time period is t. What is the time period? This is actually, diagram is not clear here. This is wrong actually, you know. Suspension O at a distance of 3L by 4. It's below the point of suspension. So this should be below the point of suspension, means somewhere here. That's given mistake actually. But here it's given clearly. The diagram is given wrong, but here it's given clearly. So this is the thing actually, right? Chalo. So what will happen? After meeting this suspension, this particular pendulum bob will be like this. Only L by 4, means this will become like some suspension here. This will obstruct it. So only this much is the oscillation, right? From here till here, from here to here, this is the kind of oscillation here. But here it is, oscillation is like this, here to here. So from here to here, A to B, what is the time period? 2 pi into root L by G. What is the time period in this case? From here to here, 2 pi into root of L by 4G. That's nothing but 1 by 2 root of L by G. Your T dash will be T by 2. Okay? Right. So what is the total time for the pendulum to go back to its initial position? If it wants to go back here, from here to here, here to here, then here to here, that is T by 2. Here to here, that is T dash by 2. So what is the total time? T by 2 plus T dash by 2. That's nothing but T by 2 plus T by 4. So that is 3T by 4. That's it. Understand? Right. Next. A body is projected up with a velocity equal to 3 by 4 of the escape velocity from the surface of Earth, and the height it reaches from the center of the Earth is. So, if you project the body from here, it's going to reach some maximum height and it comes to rest. That's the situation given here. So what is the energy you are giving here? Minus of GMM by R of M. Finally, when it reaches to this point, what is the thing? GMM by R. Okay, so let's write it as R, where R is the distance from here direct. from the center to that point. That's the potential energy at that point minus of JMM by R. Substitute the value of V. V is what? GMM, so minus 1 by R plus 9 by 16 R. That's it. Solve it. Okay, you will be getting some 16 R by 7 you will be getting. Okay, 29. Density of plant is constant. Then the curve between G and the surface, G and the surface. What is the G and surface? G equals Gm by R. G equals Gm by R square. Density is constant, so multiply by R and R here. So this is sum and multiply by 4 by 3 pi, and here also 4 by 3 pi. What is this here? Mass by volume, 4 by 3 pi R cube. That's nothing but G into density into 4 by 3 pi into R you will be getting. So if you draw the graph between G and R, what is this? It's a straight line. Straight line. That's it. Understand? Electric field lines are coming out of a equipotential surface. Equipotential surface. From equipotential surface, they'll be coming perpendicular to the surface, because there should not be any electric field component along the surface. Okay. Generally, you can see here, right? Equipotential surfaces. Electric field will be like this if you take a point charge. These are the equipotential surfaces, right? What do you see here? This is a perpendicular, right? So they are perpendicular to surface. That's it. Thin uniform rods of each mass m and length L are placed. Then the moment of inertia of system about z axis. So this you can solve it directly. I am giving you the answer. This is 2 ml square by 3. It's a very simple question. Moment of inertia. So a disk is given. Then the disk comes to rest after moving some distance. After moving the distance, the disk is going to come to rest. So the total angular momentum of the disk will be 0, right? It's completely going to be rest. Initially what? mv0 r plus ICM omega. What is ICM? mr square by 2 omega naught. And these two are in the opposite direction, right? Initial angular momentum should be equals to final angular momentum. Finally, angular momentum should be 0. Angular momentum, you know, right? mvr plus ICM omega for a body which is rolling as well as translating. Rotational plus translation. This is the formula. mvcm r plus ICM omega. So this is the angular momentum initially. Finally, it should be 0 because it's going to come to rest. So what do you say from this? Right? V naught equals to r omega naught by 2. 1 by 2. V naught by r omega naught. That's it. It's a disk. So moment of inertia is mr square by 2. Ball of mass m approaches a ball of mass capital M with a speed and along the normal. The speed of the ball is this, then the speed of the ball after elastic collision. So ball is moving like this, there is a ball coming like this. Let's say this is 1, this is 2. Speed of ball will be same. u2 equals to v2 equals to 1. It will be same only. After collision, before collision doesn't affect, right? What is the formula for E? v2 minus v1 by u1 minus u2. So this is coming in the negative side. So minus 1, right? For ball, u1 is what? 2 plus 2 in this side. So substitute with the signs here. Elastic collision means 1. v2 is what here? Minus 1. v1 we don't know. We had to find out. u1 plus 2. u2 minus 1. So it's minus of 1 plus v1 by 3. So 1 plus v1 equals to minus 3. So v1 equals to minus 4. Minus 4 means what? towards the wall or away from wall? Away from the wall. You can look back and okay, understand, try to understand. Energy released in the reaction. What is the binding energy of products? Binding energy of products is 110 into 8.2 plus 80 into 8.1. This is the binding energy of products. 110 nucleons are there and binding energy per nucleon is 8.2. Binding energy per nucleon multiplied by number of nucleons. It's the total binding energy of A. Total binding energy of B. Minus binding energy of this thing. 200 into its binding energy per nucleon is 7.4. So that if you simplify, you will be getting it as 70 MeV is the energy in the reaction. Energy in the reaction you will be getting. Energy of products, binding energy of products minus binding energy of reactants. That gives you the energy of the reaction. Magnitude of force acting on a body varies with time as shown here. Then the force on the body from t equals to 4 to t equals to 16. 4 to 16 here. 4 to 16 total impulse they are asking here, that impulse equals to change in momentum, which is equals to integral f dt. It means this is the area under the curve. Area under curve. They are asking from where? 4 to 16 only. 4 to 16, what is the area? This is the area. Only this much. This particular area we need to calculate. And that area is your half into, for this thing, this trapezium, sum of the parallel sides, that is 200 plus 800 into separation between them is 2 plus this triangle half into base into height. So this, if you calculate, you are actually getting 5 into 10 power minus 3 here. They have given it is wrong. Option B they have given, but it should be cancelled. Okay, this question should be cancelled. Or else they should ask the force from t equals to 0 to 16. Then you can add this particular area also. Then you will be getting the answer. Understand? So this should be cancelled here, because the option is not correct. Now let's look into question number 36. So linear mass density and all these things. The position of center of mass. Position of center of mass, you remember the formula xcm equals to integral x dm by integral dm. And dm is also written as lambda into dx. So in that way, lambda is kx square dx divided by kx square dx. So if you solve this thing, you will be getting it as 3L by 4. I think 3L by 4. You know integration, right? K x cube is what? X power 4 by 4 divided by k x square integration is what? X cube by 3. So k cancel, x cube x power 4, you will be left with x. That's nothing but 3L by 4. Limits are 0 to L. 0 to L. So you will be getting 3L by 4. Understand? Okay? 3L by 4. I'm not writing here. Leave it. Next. Hydrogen atom is moving at a speed v. Observe a photon of wavelength this, then the value of v is. So it's moving with a speed v. A photon is coming here and it stops. The meaning is final momentum is 0. Final momentum is 0 means initial momentum of this plus this should be 0. What is the momentum of this? Mass into velocity, and this is hc by lambda. Sorry, h by lambda. So substitute the values here. The values should be taken here properly. The hydrogen atom, it's 1.67 into 10 power minus 27. Its mass is 1.67 into 10 power minus 27, and speed v, h value you have to substitute, and lambda value is 122 nanometer, 110 power minus 9. So you will be getting the value of v. Understand? So that's what the thing here, that is 3.25 you are going to get. in a common emitter amplifier using output resistance of 5000 and input resistance of 2000, if the peak value of input voltage is 10 millivolt and beta is 50, then find the peak value of output voltage. And in this case you can apply the formula of beta here. What is beta? Beta is collector by base, and this collector current you can write it here. Okay, V equals IR, I equals to V by R. V is input voltage, that is 10 millivolt. R, input resistance of 2000. Okay, so beta value is given to you. Then you will get the IB is this thing for us, right? IB is this thing for us. Then you will be getting the IC from this. IC you will be getting here, and after getting IC, then V output equals to IR. Okay, R output voltage, output resistance is given to you. This current you substitute, then you will get the VO. Okay, so that's 1.25. The operation performed by the circuit, this you can solve it. Gate, okay, this is A bar you are going to get, and this is B bar, and you have A bar plus B bar, and this is a okay. So that's actually giving you this is the okay. So the answer for this is AND gate you are going to get. AND gate. Just put the values and check here. 1 or whatever here. 1 you take here, also you take 1, and like that you take a table and truth table, and you can get it, or you can get it by using some formula also. This is actually you know the operations, so this is what you are going to get by formula also. Understand? Right. Next, electric field and electric potential, E and B. Then what do you say about these things? Yeah, just try to look at some cases, okay, there you can able to relate here. You take a point charge, or you take a sphere and all. You know the conducting spheres. In conducting sphere, the electric field will be 0, but still there will be potential, right? So electric field is 0, still there will be potential. So this is not correct. Yes or no? Right? And if potential is 0, E must be 0. So that's also not possible here. Okay. Maybe 0. Yeah, this is fine. Whenever they say this kind of things, just check here. Must means definitely it's like strict thing, right? Just need to, it must be 0. So there's a chances say somewhere it can miss. So that's what you need to see here by comparing with the things. E is not 0, but V may be 0. Yeah. Yes. Potential can be 0, but electric field may not be 0. Just okay. Some case of dipole or something you try to imagine, where the potential could be 0, but still the okay electric field may be present over there. Okay, so that's what you can check from some particular cases, and you can able to answer it. Okay, right. Next, initially K1 is closed. Now if K2 is also closed, then find the heat dissipated in the resistance of the connecting wires. So this is actually a very big question. It's not that easy, because I don't know how he has given here. It's a very lengthy question here actually. See, initially when K1 is closed, you know that only this capacitor works here. These two will be short circuited when only K1 is closed. So that time the charge will be CV, right? That time the charge is CV here. Now later when you close K1 and K2, okay, the situation will be like this. Okay, when K1 and K2 are closed here, the situation is like this. So initially it's Q equals to CV you are having here. Then you assume the potential as, let's say, 0 here. V, the potential at this point, you take it as X. So you can see this is going to form an isolated system, right? These three plates is going to form an isolated system here. So when these plates are going to form an isolated, where it is connected, it's connected here, right? That's the thing here. That's a drawn diagram thing here. See, this is actually connected here. That's what I'm looking here. This is the thing. Yeah, this forms an isolated system. Okay, so if this is forming isolated system, what is the charge on this plate? This plate is what? Minus C into V minus X. Charge on this plate will be C into X minus V. This is V, right? Potential at this point, because this is V, this is also V. Then charge on this plate will be C into X minus 0. So these three should be 0 here. Isolated system. Initial charge should be equals to final charge. Then this is the thing here. So when you solve this, you are going to get the X value as V by 3, 2V by 3. X value as 2V by 3. Then the final energy stored in the particular system also you can write here. Final energy stored in the system. Initial energy is how much here? Initial energy in the capacitor system is half CV square. Then the final energy stored in the system you can write half C into, what is the charge on the system here? X is 2V by 3, so this will be CV by 3. Okay, so or you can write okay, half CV square. What is the potential difference here? X is 2V by 3, so it is V minus 2V by 3, so V by 3 whole square plus charge potential and energy of this will be half C 2V by 3, V by 3, again it's V by 3 whole square plus half C, and what is this here? V square, and this will be half C, X is 2V by 3, so you'll be getting 2V by 3 whole square. So that's overall final energy stored in the system will be 15 CV square by 18. This is how you need to solve it. So this is initial energy and final energy. So heat, so you can also see through the battery how much charge is actually moving here. Initial charge is CV. Finally, if you observe the charge on these plates, here, okay, CV is the charge here. Here you have minus CV, and here you have minus 2 CV by 3. So charge transferred through the battery will be 2 CV by 3, because initially already CV is there. Here already minus CV is there. But here how much is coming? Minus 2 CV by 3. Initially CV is there, finally minus 2 CV by 3 is coming. So through the battery 2 CV by 3 is traveling here. So when 2 CV by 3 is traveling here, so you can write so work done by battery plus initial energy equals to final energy stored plus heat released. So this is the concept you need to apply here. Work done by battery will be 2 CV by 3 charges moving across the battery. So 2 CV by 3 into V plus initial energy stored, that is half CV square, right? So final energy is 15 CV square by 18 plus heat. So if you solve this thing, then you are going to get the heat in the answer as option C. That is option C, 1 by 3 CV square you are going to get. So this is a JEE question. I don't know why they gave here. Somehow it's misplaced or something is missing in the question. Maybe they might try to make it simple, but somehow it went tough. So, but this is the concept here you need to apply, then only you will get the answer here. Understand? So that's the thing about this question. All the bulbs are identical, then which bulb shines brightly? Again use the logic. You know that current in the form of current you write, then I square into R is the power. You know the current I here goes here. Here the current gets divided. So definitely here power will be less. So power is more for 1 as well as 5. 1 and 5. Here you can see the magnetic force on the electron at this instant. You can write magnetic force will be obviously Q into V cross B, right? V bar cross B bar. If the electron velocity is in this direction, due to this, definitely there is a magnetic field in this direction here, right? If you assume this is the direction here, then the magnetic field will be like this. So angle between B and V will be 180, so force will be obviously 0 here. If at all, let's say V is in some direction, and if you want to write, then you can check the magnetic field is actually nu naught I by 4 pi x square plus r square whole power 3 by 2 into nu naught I r square. This is actually formula here, nu naught I r square by 4 pi into x square plus r square whole power 3 by 2. This is the B formula here, but that is also not there here anywhere. So it's none of this. Understand? Right. Of course the force is 0 here, but in general if you want to write the formula also, this you need to consider here. Next. Then the current is flowing, then what do you say about the forces? So you can see if you take the small segments, all these segments, what is the direction of force here? Force is ideal cross B. So ideal is in this direction, B bar is into the plane, so force is upwards, right? Ideal is this direction, B bar is into the plane, so force is downwards. The right hand rule, you should know it, okay? Then here also force is like this, so force is in this direction, so it gets expands. The coil gets expands. The material suitable for making electromagnets should have the electromagnet means the temporary things, okay? It's not a permanent magnet, so only when you send a current, then that time only it has to we can see what we can say, when you send current, that time only it should behave as a magnet. So it should maintain low magnetic thing here, means immediately when your current becomes 0, the magnetic property should get vanished. So for those type of materials, you should have low retentivity and low corrosivity. Understand? So that's the thing. For electromagnets, you should have both low retentivity as well as low corrosivity, because they are not permanent magnets. So that's the thing. Okay, everybody, see you then. So that's all about these questions. I hope you people have understood. Okay, see you.